This is part 2 of 4.5. So we have a kite that is 80 feet off the ground. If you pull the string tight, the angle of elevation is 43 degrees. Find the length of the string. Remember, we're going to use the mnemonic SOHCAHTOA. If this is our theta, our angle, what is the name of that side? Opposite. And then the name of this side, hypotenuse. And then, of course, this one is the adjacent. We're not going to use it. If I switched theta to the other side, what would happen? The O and the A would flip. Does everybody understand that? Adjacent is the geometric word for next to. So the adjacent leg touches theta, and the opposite leg does not, and then the hypotenuse never changes. And for that reason, we cannot choose the right angle as our theta, because then O and H become the same side, and then you end up with two adjacents. Now, there is a formula that you can use, but it's not one that you've learned yet. So, O and H is going to require that I select the sine. So the sine of 43 is 80 over H. Does anybody not understand that? Okay, where'd you get stuck? H is always the long side. No. Well, it depends on the ratio. So these are your ratios. So O divided by H, A divided by H, and O divided by A. So this one used O and H, so I had to choose the sine. And we know that sine is the O side divided by the H side. Is that what you were asking? Yeah, so in this case, H is always on the bottom. Now, there are three other ratios. So we have sine, cosine, and tangent. There are three others. There's another one that has H divided by O, and H divided by A, and A divided by O. And you'll learn those later. But for now, we're just sticking with sine, cosine, and tangent. O divided by H gives me this. And there are only two types of problems. Either we switch the trig ratio and the variable, or we multiply by the denominator. Is this a multiply or a switch problem? It's a switch problem because the H is on bottom. So I switch places, and I get H equals 80 divided by the sine of 43. So I would just type that in my calculator and then round to the nearest tenth. Let's do another one, or the next one. Oh, it's time to learn the other ratios. So the sine of theta is O over H. The cosine of theta is A over H. The tangent of theta is O divided by A. The other three ratios are called secant, cosecant, and cotangent. All right. Cosecant is abbreviated CSC, and it is the ratio H divided by O. Secant is H divided by A, and cotangent is abbreviated COT, and it is A over O. And again, don't say sec or cot. It's secant, cosecant, and cotangent. Now, how do we remember these? Well, if I were in charge of naming them, I probably would have named them a little bit better, because sine and cosine are not actually opposites, but tangent and cotangent are. So it's a little bit weird that way. Here's how I remember it. This one has a co, and this one does not. This one has a co, and this one does not. This one has a co, and this one does not. And I don't have any fancy mnemonic for cosecant, secant, and cotangent. Okay, just remember that cosecant is the reciprocal of the sine, secant is the reciprocal of the cosine, and cotangent is the reciprocal of the tangent. So here, what two sides do I have? What is the name of the side that's length 3? Well, it touches the angle, and the leg that touches the angle is referred to as the adjacent. And length 4 is which side? Hypotenuse. Okay. So, what is the secant of theta? So, secant is h over a. So, the secant of theta is going to be 4 over 3. Does everybody understand that? Anybody confused? All right. The tangent of theta. How am I going to do the tangent of theta? Well, I need the O divided by the A. I don't know the O, so I need to calculate it. 3 squared plus O squared equals 4 squared. So O squared equals 16 minus 9. No, this is not a 3, 4, 5. Would be nice if it was. So 16 minus 9 is 7. Square root of 7. So this is root 7. And the tangent of theta is the O side divided by the A side. So that would be root 7 over 3. What is the sine of theta? Sine is O divided by H. So that would be root 7 over 4. What if it asked me for the cotangent? What would the cotangent of theta be? Well, that's the A side divided by the O side. That would be 4 over root 7, but I'm not allowed to leave it in that form. I need to times it by root 7 over root 7, and that yields 4 root 7 over 7. Okay. Okay. The three triangles below are similar because they have the same angles. For each triangle, find the ratio of the length of the side adjacent to the length of the hypotenuse. So I want to know what is 9.24 divided by 11.24. So 9.24 divided by 11.24, and I get 0.822. If I do the next one, 36.96 divided by 44.96, I'm going to get 0.822. And 64.68 divided by 78.68, I get the same thing. Well, what is the cosine of 34.7? What do you notice? I mean, it's off a little bit because we rounded. So that ratio, so the cosine of 34.7 is equal to 0.822, no matter how big the triangle is. That's what a trig ratio tells you. That angle, 34.7, will always build a ratio of the A side divided by the H side of 0.822, no matter how big the triangle is. So every single triangle with this angle will give the same trig ratio. Always. That's what trigonometry does. Okay. How do we find the area of this triangle? Well, the area of a triangle is 1/2 base times height. So all I need is to figure out the base. How will I do that? This is O and this is A. So the tangent of 62 equals 18 over A. Swap those. 18, no, how about A equals 18 over the tangent of 62. So that goes there. And then the formula is just 1/2 times that times 18. Notice this says do not round any intermediate computations. Why would it say that? Yeah, this is going to be a decimal. So 18 divided by the tangent of 62. Should I round that to 9.6? No, because I'm going to use 9.6 for a future calculation, and if I round the original calculation, then the final calculation might be off by a little bit. So I'm just going to do 1/2 times, and I push second answer, and it will plug all those numbers in for me, and then times that by 18. And that's going to be the area. All right, next. Okay, I don't know why this is in this. Nope, not that one. I really wish they would have put this somewhere else. Oh, I see what they're doing. Okay. All right. There is another formula for this, which is we're not ready for yet, so I was a little sad that they did this. Okay. So here's what we need to do. We need to find a way to calculate that. I need a right angle somewhere. Okay. Well, the only angle I know is that, which is 44. So if I build a right angle, okay, I know a little bit about that triangle, right? So this big triangle here, if that's a right angle, then I know that this is 5. So, oh, is that how I want to do it? What? Oh, sorry. We're going to get rid of this one. There is a way to do this using right triangles, but it's much harder. There is another formula out there that's really easy to use, but the formula is not going to make sense yet because there's some trig stuff that we haven't learned. So I'm going to go in and chuck this one. Yeah. All right. All right. Relationship between sines and cosines. So if I had this, oh, well, they already drew me one. What is the cosine of t? Cosine is a divided by h, so that would be u divided by v. How about the sine of u? Well, sine is o divided by a, or o divided by h, but when I move from t to u, the opposite and the adjacent switch places, so this is also u over v. Okay. Well, how does angle T compare to angle U? What do I know about T and U together? They're complementary. They add to be 90. So the sine of 30 degrees is going to be equal to the cosine of 60 degrees. Because this angle and this angle always add to be 90. So let's check that in our calculator. If I said the cosine of 30 and the sine of 60, oh, I did it backwards, but whatever. So if you know that the cosine of 10 is a particular ratio, then the sine of 80 is always going to be that exact same ratio, which is what this question is getting at. So here, those two angles are complementary. Then you're going to figure it out and then select all of them that are true. The sine of t equals the cosine of u, and the cosine of t equals the sine of u. And so if the sine of 29 is equal to what? Well, that would just be 90 minus 29, so the cosine of 61. Okay, that's it. Get to work. Did I not record? Oh, there we are. We're here. We're recording.